Hi everybody and welcome back to task 2.5. In today's video, we're going to be going over the ideas from task 2.5 in case you missed it in class or in case you just need some extra review. So we're actually not going to start on the first page of the task. We're going to start on the second page of the task. So you're going to want to find the page in your packet that looks like this. And today we're still going to be talking about graphing a line without making a table of values. We're just going to be doing it in a slightly different way because we're going to have a slightly different type of equation. Today's type of equation is something called slope-intercept form. So when we first learned how to write the equation of a line, we said sometimes your equations look like this. F of x or y is just equal to the starting output value plus or minus your slope times x. Now, when we saw equations like this, where there was just an x in the equation, there was no parentheses, we said you got an equation like this because the starting x value would have been 0. If the starting x value was anything that wasn't a 0, you would have had to have a parentheses with x minus that number. So by seeing an equation where there wasn't a parentheses, you would have known the starting x value must have been 0 at the beginning. We call this type of equation slope-intercept form, which is a slightly different version of point-slope form, which is what we talked about last time. In slope-intercept form, rather than writing it out using all of these long words, what we often say is something that looks like this, and you may have seen this before. Y or f of x is equal to b plus or minus mx. Or sometimes people write it as y equals positive or negative m x plus b. Now you might be wondering, why is this equation called slope-intercept form instead of point-slope form? Well, the reason is because when your starting x value is 0, that point on the graph has a special name because of its location. All of those points are going to be on the y-axis, which means those are all called y-intercepts. So this is called slope-intercept form because the starting value will always be the y-intercept of the graph. In these equations, the b stands for the point where you begin. So it's the starting y value of the graph. And in these equations, because there's no parentheses by the x, because the x is just x, the starting x value is always just 0. Now, it's never going to be anything other than 0 if there's no parentheses there. As always, the m is your slope. So when you look at an equation like this, your job is going to be to find the key features of the graph, the starting point and the slope, and then make the graph. In these equations, the m, just like point-slope form, represents the slope. This is always going to be the number that's multiplied by the x, just like in point-slope form. It's multiplied by wherever you see the x. In this problem, the reason we're calling this b is that b represents the starting y value which we call the Y-intercept of the line. That's why we give this equation a slightly different name, which is slope-intercept form instead of point-slope form. It's not just a random point, it's a special point. It's the Y-intercept. Remember, the x-coordinate of the y-intercept is always going to be 0. And we can tell that from the equation because there's no number being added or subtracted by the x. And the b value will always be the number that doesn't have an x. So if you look at this equation, the b does not have an x attached to it. The b does not have an x attached to it. So the b value will always be the number without an x. Let's practice identifying these from the equation. So in this first equation, we're going to try to find the y-intercept and the slope. You'll notice that I didn't write point and slope because it's not just any old point, it's a y-intercept. It's a special point. In this equation, the y-intercept would be 3 because that's the number in the equation that is not attached to an x. It's not multiplied by the x. And so the y-intercept would be the point 0, 3, because the starting x value would always just be 0. The slope is going to be the number that's multiplied by x. In this case, that would be -1, and as always, I can write divided by 1 to make it look like a fraction so that I can easily see rise over run. This would be a decreasing function because the slope is negative. In the next equation, my starting y value would be the -1. And because there's no parentheses by the x, I know that the starting x is 0, which makes the -1 the y-intercept. My slope would be 3/5 because that's the number that's multiplied by x. mx. M is the slope. Because this slope is positive, my graph is going to be increasing because the slope is positive. Let's try one more. When I see an equation like this, I know that in my y-intercept, my starting x value is going to be 0 because there's no parentheses here. And my starting y value will be -6 because that's the number in the equation that does not have an x. It's mx, and then the b is separate. My slope would be -1/2 because that is the number that's multiplied by x. This graph would be a decreasing graph because the slope is negative. Now, let's put this all together and actually make some graphs. So I'm going to go ahead and turn the page, and let's actually make some graphs here. So when I look at these equations, what my brain needs to do is to say, oh my gosh, when I see this equation and there's no parentheses, I know that I can find a y-intercept and a slope. My y-intercept is going to look like this. Starting x is 0 because there's no parentheses by the x. Starting y is -3 because that's the number that's not attached to x. And my starting slope is 3/4. When I want to make my graph, I'm going to graph my y-intercept first. So that value is going to be at the 0, -3 point, which is right there. And then just like before, I'm going to do rise over run. So I'm going to go up 3 and then right 4. So 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. I can also go backwards. So if I want to stay in this line, I'm just going to go down 3 and then left 4. Same thing here, down 3 and then left 4. And then I can just draw my nice straight line on the graph. Now in the next equation, my y-intercept would be the point 0, 6. And again, I know that it's 0 because there's no parentheses by the x, so the starting x must have been 0. And the slope would be -2. I'm going to write this as -2/1 to make it easier for me to graph. Now I'm going to graph my 0, 6 first. So 0, 6 would be right here. It's on the y-axis because it's a y-intercept. And then to graph this slope, I would go down 2 because the top number is negative and then right 1. So 1, 2, right 1. 1, 2, right 1. 1, 2, right 1. 1, 2, right 1. I'm going to keep going down 2, right 1, down 2, right 1. I could also go up 2, left 1 and kind of reverse myself to get some extra points on the other side of that starting point. And now I'm just going to draw my nice straight line on my graph through all of those points with arrows at the end. To summarize, we've learned about 2 different types of equations of lines. One of them is called point-slope form, and one of them is called slope-intercept form. The reason that this type of equation, which has a parentheses, is called point-slope form is that in this equation, we can immediately identify the starting point and the slope. The starting point here, the x coordinate would be +4 because it's the opposite of the -4 that I see in the equation right next to the letter x. And the y coordinate would be the +2 because that's the number that is not in any way connected to the x. And my slope would be 2. Now that slope would be 2/1. I like to write it as 2/1 so that I have a rise and a run. On the graph, I would graph my starting point at 4, 2. So the x is 4, the y is 2. And then from there, to get more points, I would rise 2, run 1. Rise 2, run 1. I'm going up 2 over 1. I could also go backwards, down 2, left 1, down 2, left 1, down 2, left 1, and then draw a nice straight line through those points. Now, when we learned to write the equation of a line, we noticed that sometimes our equations looked like this with no parentheses, and that always happened when the x-coordinate was 0 to start with. So in this type of equation, we actually give the starting point a special name. We call the starting point the y-intercept, which is a special name because that's going to be a place on the graph where you're going to be on top of the y-axis since the x is going to be 0. So my starting point here would have an x-coordinate of 0 because there's no parentheses by the x, and a y-coordinate of -6. My slope would be +2. Now I'm going to write that as 2/1 because I want to be able to see that I should rise 2 and then run 1. On the graph, when I graph this, I would start with the point 0, -6, which is right here, and I would go up 2, right 1, up 2, right 1, until I've filled in as many points on the graph as I can. Then I can go backwards. I can go down 2, left 1, and then I can connect my dots into a nice straight line. One thing that I think is interesting is if you look at these 2 lines, if you were to lay these graphs on top of each other, the lines would be exactly the same line. The only difference is that this equation used the point 4, 2 as the starting point, and this equation used the point 0, -6. So what we're really doing here is the same thing, just different forms of writing the equation. Now we have one last thing to talk about today, and that is to talk about something called simplifying an expression. So far, we've already reviewed how to distribute and how to combine like terms. When we're simplifying an expression, we're going to want to do both of those things. So far, we've reviewed both, but what if we need to do both? We're going to follow the order of operations. You may have heard of the order of operations before. It looks like this. It says you start with parentheses, then you do exponents, multiplication and division, and addition and subtraction. Distributing involves multiplication. And combining like terms involves addition and subtraction. So when we're simplifying an expression, first, we always distribute, and then we always combine like terms. Let's look at an example. In this first problem, I would want to simplify this as much as possible. So step number 1 is going to be to distribute. Now, when I'm looking at this problem, I'm noticing I need to distribute the 2, and I'm going to distribute that to the 3x and the minus 4. I am not going to distribute to the minus 2x because that is not inside the parentheses. When I distribute the number 2, 2 times 3 is 6x, and 2 times minus 4 is minus 8. Now, since the minus 2x was not inside the parentheses, I'm just going to copy him down without changing him. I like to call that drop it like it's hot. Next, I'm going to combine like terms. So if I look at this new expression that I have, I can see that the 6x and the minus 2x are like terms. When I combine those, 6 minus 2 makes 4x. There is nothing to combine with the minus 8. There's no like terms. So I would just copy down the minus 8 and not change anything. I like to call that drop it like it's hot. This simplified expression would be my final answer. Let's do 2 more examples together. So let's start with number 1 here. For problem number 1, I'm noticing I'm going to distribute first. In this problem, I'm going to distribute the 2. 2 times x would give me positive 2x, and 2 times 3 would give me positive 6. Since the 7 is not inside the parentheses, I'm just going to copy it down. I like to call that drop it like it's hot. Then I'm also going to combine like terms. I'm noticing that the 7 and the positive 6 are like terms because they're both numbers that don't have any x's. 7 plus 6 would be 13. And then I'm just going to drop down the positive 2x. It doesn't get combined with anything because it doesn't have any like terms. And that would be your final answer. Let's try one more problem. So for problem number 2, we're going to take the negative 4 and distribute. Negative 4 times x would be negative 4x. Negative 4 times negative 1 would be positive 4. And then I'm just going to copy down this x. I'm not going to change anything because there are no like terms. It doesn't have anything to be distributed to because it's not inside the parentheses. Now I'm going to look for like terms. So negative 4x plus 1x would be negative 3x. And then I'm just going to drop down the positive 4 because it doesn't have anything to combine with since it doesn't have any like terms. And that is how we would simplify an expression when we need to do distributing and combining like terms in the same problem. Thank you guys so much for watching. I hope you have a wonderful afternoon, and we'll see you soon.